Class 10th, Chapter Electricity, Topic Resistance. From the statement of Ohm's law, V equal to IR, we got a constant R which we called as the resistance. Now let us try to understand what do we mean by this resistance and what is its significance. Resistance literally means the opposition, and in this case it is the opposition to the flow of current. It is a physical quantity and we can measure it using a multimeter. Its SI unit is ohm. Now what is the cause of this resistance? For this, let us consider a conductor AB. Now if you apply a potential difference across its end, you know that a current will start flowing through it. And current is nothing but the flow of electrons. So we can say that when the electrons drift from point A to point B, they suffer collision with its fellow electrons as well as the immobile ions which come in its path. So it is these collisions which give rise to the opposition or obstruction to the flow of current. Now, what kind of questions can be asked from this topic? First can be the direct questions like define resistance or what is its unit, or you may be asked to define 1 ohm. Now to define unit of any physical quantity, in most of the cases it can be done with the help of the formula. Now the formula in this case is V equal to IR. So if I take V as 1 volt and I as 1 ampere, then R is equal to 1. So can we say that resistance of a conductor is 1 ohm when 1 volt of potential difference applied across its end will give a current of 1 ampere. Now before we move on to the next topic, we have to remember a very important thing, that is in the formula V equal to IR, resistance is a constant provided the temperature remains the same. Now what do we mean by this? It means if you increase potential difference, that will increase your current only, not the resistance. Let's understand better with the help of this example. If you connect a 10 ohm wire to 220 volt, so how much would be the current? You can use the formula I equal to V by R. So the current comes out to be 22 ampere. Now same wire, if we connect to 110 volt, then I will be equal to 110 upon 10, that is 11 ampere. So decreasing potential difference will decrease current and vice versa. But does that mean the resistance cannot be changed at all? No, that's not the case. So let us see how and under what condition resistance will change. For this, you can perform a simple activity using the given apparatus. In the first case, we can insert a nichrome wire of length L and area of cross section A in the given gap PQ. In case 2, we can use the wire of same material, but let's increase its length to 12 and keeping the thickness or the area of cross section constant. In case 3, we'll keep the length same, but now we will change the area of cross section. So let us say we double the area of cross section. And in case 4, we keep length and area same as in case 1, that is L and A, but we change the material of the wire. That means now instead of nichrome wire, we can take copper wire. Now in all the 4 cases, we are keeping the battery same. So that means we just have to measure the current to calculate the resistance using the formula R is equal to V upon I. Now when you will see the observation of this activity, what you will observe? Now from the observation of this activity, we will see that as we increase the length in case 2, keeping the area of cross section same, the resistance also increases. If we take 2-3 observation for this, so what we can say that as you increase the length, the resistance also increases. Otherwise also we can say that when the length increases, since the number of collision will also increase, so your resistance will increase. Now in case 3, you keep the length same but you increase the area of cross section. Now from the observation of activity, what we'll observe, we'll see that resistance is inversely proportional to area. Now what do we mean by this? It means when you increase the area, the resistance decreases. Okay, we can justify it using the collision concept. That means since area of cross section or thickness is more, so more number of electrons can cross. Okay, that means your conductance will increase, which will be decreasing your resistance. Now in case 4, when we change the material keeping the length and area same, then also you will observe that resistance will change, which means we can say that resistance not only depend upon length and area of cross section, it also depends on the material of the wire. So if you combine the first two observations, that is R is proportional to L and R is inversely proportional to area, so we can say that R is proportional to L by A. As we remove the proportionality sign, we get R is equal to rho L by A, where rho is a proportionality constant known as resistivity. Now this constant is a characteristic property of the material. You can also say that this constant accounts for the case 4, that is the dependence of resistance on the material of the wire. Now here we have to note a very important thing, that both resistance and resistivity depend upon the temperature. So what kind of question can come from this particular topic? It can be, what are the various factors on which the resistance of a wire depends? So the answer for that will be length of the conductor, area of cross section of the conductor, nature of the material and temperature. You can also be asked to define resistivity. For that, let us go back to the formula R is equal to rho L by A. Now here if you take length as 1 meter and area as 1 meter square, then your resistance becomes equal to resistivity. So you can say that resistivity is nothing but the resistance of a conductor of unit length and unit area of cross section. आप ऐसे समझ सकते हो, since the resistivity is the resistance of unit cube of a conductor, that is the reason it will not change with length and area of cross section. To understand this better, let us take the example of a building. अब जो आपका brick का size है, चाहे आपके room में लगी हो या फिर आपके bathroom में, so that size remains the same even if you are changing the size of the room. Same way, जब आप resistance निकालते हो तो unit cube का resistance तो same रहेगा and that unit cube resistance is nothing but resistivity. The next kind of questions which can come from this particular topic are numericals to calculate resistance and resistivity and how they will change under different conditions. This we'll discuss in the next video. Thank you.